We've just discussed AI and data. Now, let's think about that in the real world by returning to something we discussed in Module 1 where we introduced the trolley problem. If you recall, when we discussed the trolley problem, we talked about two scenarios where a runaway trolley was about to hit a group of people. In one of the scenarios, you had the choice to divert the trolley with a switch, which would change the trolley's direction and hit only one person, who was killed by the impact. In the second scenario, instead of a switch, however, you would have to push a person in front of the trolley to stop it, thus saving the group of 5, but killing the person you pushed. Nearly everybody chooses to divert the trolley with the switch, and nearly all object to pushing a person into its path. Now, this dichotomy highlights the important aspect of proximity in people's decision making, such as how proximate or close we are to a given context, or how personal it feels can alter our decisions completely.
In recent years, the trolley problem has morphed into other dilemmas that have become popular in the news and in the media. This is especially true for AI and self-driving cars. With autonomous vehicles on the horizon, self-driving cars have to handle choices about accidents, like causing a small accident to prevent a larger one.
So this time, for our hypothetical scenario, instead of a runaway trolley, think of a self-driving car. And instead of a switch to redirect the car, the switch is the self-driving car's programming. So for example, imagine a self-driving car driving at high speeds with 2 passengers, where suddenly 3 pedestrians enter the crosswalk in front of the car. The car has no chance of stopping. Should the car hit the 3 pedestrians, who will likely get killed, or crash into a concrete barrier, which would lead to the 2 passengers likely dying?
Now imagine that you're the passenger of the car. What would your answer be then? And what car would you ultimately buy? A car that saves you, the passenger, at all costs in any scenario, or one that minimizes harm to all, but which ultimately may affect you?
If there was no self-driving vehicle and you were the driver, whatever happened would be understood as maybe a reaction, a panic decision, definitely not something deliberate. However, in the case of a self-driving vehicle, if a programmer has developed software so the vehicle will make certain types of decisions depending on the context, then in an accident where people are harmed, is the programmer responsible for that? Is the car manufacturer responsible for that? Or who is responsible? Is there ever an answer to what a self-driving car should do?
Now, researchers at MIT, the Massachusetts Institute of Technology, further revived this moral quandary back in 2014. They created a website that they called The Moral Machine, and through that website, respondents around the world were asked to decide in various self-driving vehicle scenarios, such as whether to kill an old man or an old woman or a young girl, the car passenger or pedestrians, and many other similar questions. Since its launch, the experiment has generated millions of decisions, and analysis of the data was presented in a paper in the scientific journal Nature in 2018.
The study sparked a lot of debate about ethics in technology, which is the purpose of this course. So given that, we'd like to ask you a few questions. 1, who should you trust? Should we trust AI, or should we trust humans? 2, who's responsible if something bad happens? So in the context of an autonomous driven vehicle, is the car manufacturer responsible? Is the software programmer responsible, or another stakeholder? And 3rd, culture. What is the role of culture in all of this? Let's consider these questions together.